All right, so now we're on to part 3. Like I was saying before, it gets a little bit more intricate. All right, the directions are similar in terms of what they're asking you to do. It's just you just got to do a little bit more. All right, Alex has $1.70 in nickels and dimes on his desk. There are or were 25 coins in all. All right, so write a system of equations that could be used to determine both the number of nickels, N, and the number of dimes, D, that Alex has. So they define the variables for us, which is nice. I'm going to write it again anyway, but let N equal number of nickels. Let D equal number of dimes. All right, so each nickel is worth 5 cents. I'm just going to make a note. You probably wouldn't write this, but I'm going to write it for your benefit. Each nickel is $0.05. That's the same as saying 5 cents. Each dime is 0.10 or just 0.1. All right, so if we're talking about value, there's a total of $1.70. All right, so if I take the value of each nickel, multiply it by the number of nickels, add to it the value of each dime, multiply it by the number of dimes, that should get me to 1.7. All right, or I'll write $1.70. Then there are 25 coins in all. Those coins are nickels and dimes. So if I take the number of nickels and add to it the number of dimes, I should get 25. So N plus D is equal to 25. All right, so we have a system of equations. This part was just asking us to write it. The second one's actually asking us to solve it. All right, so I'm going to rewrite it down here. And you have a few different options to get the answer, but they say they want an algebraic approach, which means that your choices are substitution or elimination. All right. If I want to do it in the calculator, I'll use X's and Y's instead of N's and D's. So find the intersection. I get 16 and 9. 16 would be the number of nickels and 9 would be the number of dimes. So again, just a way to find the answer out going into the problem so you know what you're aiming for. Here, I'll do it both ways. If I did it with substitution, N plus D is equal to 25, I'd isolate one of the variables. So instead of N plus D, I'll get rid of the D, for example. So N is equal to 25 minus D. Then I would replace the N with a 25 minus D. So 0.05, times 25 minus D plus 0.10 D is equal to 1.70. Distribute. So that's going to be 1.25 minus 0.05 D plus 0.10 D is equal to 1.70. Like terms. So I'm going to get 1.25, and that's going to be plus 0.05 D is equal to 1.70. If you're not sure, type it in. All right, then I'm going to subtract off the 1.25. It's going to get me 0.45. Divide by the 0.05. cancels, and you get a result of 9. If you're not sure again, 0.45 divided by 0.05 would get you to 9. Now they said number of nickels and number of dimes. We got the dimes and need the nickels, all right? So I'd go back to this equation here. N plus D is equal to 25. Replace the D with what we know it is now, which is a 9. N plus 9 is equal to 25. N is equal to 16. All right. Safe bet. There are 16 nickels and 9 dimes. All right, it's a good idea to actually state the final answer rather than giving the grader something to go hunting around for. It's probably there, but when I got to look for it, I might miss something. But if you put it right there in front of my face, it's a little easier. All right, so that's substitution. Let me show you with elimination. Let's see. Oh, copy it again from up here. Elimination is where you cancel one of the variables out. All right, so what I would do here is multiply my second equation by a negative 0.05. All right, and the reason I would do that, so let me rewrite the first equation again. Is so when I distribute, and it goes to each term, so I'm going to bring it down here, negative 0.05n minus 0.05d equals, I know I did the calculation already here, so 1.25. Sorry, negative 1.25. So now I'll add the two equations together down each column. So 0.05 and minus 0.05n goes to 0. 0.10d minus 0.05d is 0.05d. And then lastly here, 1.7 minus 1.25 is going to be the 0.45. So if I divide out the 0.05, I get D is equal to 9. All right, so a little bit, I would think a little bit less work, but still pretty beefy. We still have to do everything else after. This just got me the D, but whether you go this pathway or this pathway, the rest of the work is going to be the same. All right, but definitely a little on the crunchy side. Number 32 is asking for a linear regression equation, rounding everything to the nearest tenth. So this is all calculator work. So the previous problem they got you on, or actually a couple of problems they got you on the algebra, but now we're going to make up for that by letting the calculator do all the work for us. All right, and we talked about this a lot. Data entry. Make sure you type in the data correctly. Double, triple check. You don't want to lose credit for that. And 737. So I'm going to do a quick double check. So now what we type in, our columns have headings of x1, y1. So we want it to be in the form of y equals mx plus b. So now it's x1 and y1 though. So y1 and tilde mx1 plus b. Everything you have, or everything you need is here, all right? I'm gonna write it as y equals, I said to the nearest tenth. So 9.1 x minus 527.6. All right. The r value is set to the nearest tenth also. R is equal to 0.9. Then they want us to make a statement about what this tells us about the relationship between the two variables. We would say that there is a strong positive linear relationship and we would tell it between what and what? Between average heart rate and calories burned. All right, so strong positive linear relationship between average heart rate and calories burned. All right, and that's because that R value is pretty close. Well, close enough to 1 to say strong. All right, if it were 1, it would be perfect positive. If it's -1, it's perfect negative. If it's anything around 0, we say that there's no correlation. So here we say strong positive. Quadratic formula, all right? It's easy enough to flip to it now. I'll just bring you. Let's see. In this neighborhood, you have your formula sheet. All right, it's kind of hidden after like a lot of blank pages. But one of the things they give you is the quadratic formula. They also give you, other important things too. So like we just talked about y equals mx plus b. So they give that to you also. So a lot of good information. Here we're asked to solve using the quadratic formula. So we identify our a, b, and c values. Remember, it's ax squared plus bx plus c equals 0. A is equal to 1. B is equal to 4. C is equal to -3. Then you have your quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Substitution time. So we're looking at x equals -4 plus or minus the square root of 4 squared minus 4 times 1 times -3 all over 2a. So 2 times 1. So now we're going to simplify. All right, you can do it in the calculator. Just don't try to put everything into the calculator in one shot. Just focus on the tricky stuff, which is what's under the radical. And if you forget about the radical, just put the numbers in. So 4 squared minus 4 times 1 times -3. That's going to give me a 28 under the radical, so radical 28. They said simplest radical form, though. So I have to have a look at that radical 28. I'll just do that off on the side here. Break it up into the product of two radicals, one of which should be a perfect square. All right, so you think about the largest perfect square number that goes into 28, and that's going to be 4. 4 times 7 gives you 28. 7 wouldn't be able to be broken down any further. Square root of 4 is 2, so 2 radical 7. So this radical here gets replaced by this one. So we have negative 4 plus or minus 2 radical 7 over 2. And that brings us back to that bunny ears thing I was talking about earlier, because this could be simplified. So one way to do it, if you have a sum or difference in the top of a fraction and just a single term in the bottom, you can break it up, write it as two separate fractions. Negative 4 divided by 2 is negative 2. The 2's here would cancel. So negative 2 plus or minus radical 7. That's what x is going to be equal to. Wasn't a word problem, so we don't have to do the value of x is equal to. You can just write x equals. All right, number 34, solve the following system of equations. So whereas that one problem we could do it with substitution or elimination, here we kind of need to do it with substitution. However, we can put it in the calculator and at least know what the answer is supposed to be. So I'll put them both in. All right, so there are my intersections, 3, 0, and 6, 6. All right, so that tells me what I should get as a final output. Both equations are equal to y, so we could write them as equal to each other. That's the substitution part of it. So I'll make this equal to this. Because it's quadratic, we need to get everything over to the same side. Match up your like terms. The right-hand side is just going to be a 0. The left-hand side, x squared minus 9x plus 18. All right. Now, the benefit of putting it in the calculator to get a good look at the final answer is that they're clean final answers, which means that I'm not going to have to do anything funky like completing the square or quadratic formula. This is factorable. The x values of my solution would tell me what the factors are. So I know it's going to be x and x, 3 and 6. We have to get to a positive product with the two values adding up to a negative number, so they both have to be negative. We do a quick double check on that. Negative 6x, negative 3x. If I add negative 3x plus negative 6x, I get negative 9x, so we're good there. So I take my x minus 3, set it equal to 0. Same thing with my x minus 6. Add 3. Add 6. And I get x equals 3, x equals 6. But I need the y values that go along with that. All right? So all I'm going to do here is I'm going to take my y equals 2x minus 6. I'm going to plug in an x equals 3. And then I'm going to plug in an x equals 6. All right, so y is equal to 2 times 3 minus 6, which is 0. Y is equal to 2 times 6 minus 6, which is 6. All right, so that gives me an ordered pair, x comma y, 3 comma 0, x comma y, 6 comma 6. And that would be my final answer. And it corresponds with what we have on our calculator screen. So that brings us to part 4.